You're welcome to today's class. Here we have x raised to the power of 3 plus x raised to the power of 2 equals 36. So I will need to bring this 36 to the other side here. I will have x raised to the power of 3 plus x raised to the power of 2 minus 36. If I bring this 36 to the other side, I'll be left with 0 here. Okay, now I will need to break this 36 further, but before I break it, this kind of equation, I will get 3 answers here. One is real, the other 2 are not real. Okay, so let's proceed. I will need to break this 36. Here I have x raised to the power of 3 plus x raised to the power of 2 minus 27 minus 9 equals to 0. What the essence of breaking this 36 to this is that I can express this 27 to the power of 3. That is, if I say 3 raised to the power of 3, 3 raised to the power of 3 is equals to what? Is equals to 27. 3 raised to the power of 3 is equals to 27, and that tallies with this, match with this. If I say 3 raised to the power of 2, that is equals to what? 9, right? So 3 raised to the power of 2 tallies with this because it has a power of 2. It has a power of 2. This one can also be expressed as power of 3, as a power of 3. So I will match this and this together. I will match this and this together. So here I have x raised to the power of 3 minus 27 plus x raised to the power of 2 minus 9 equals to 0. So I can also write it as x raised to the power of 3 minus, I can write 27 as what? 2 raised to the power of what? Is the same thing as 3 raised to the power of 3. Okay? Plus x raised to the power of 2 minus, I can also write this 9 as 3 raised to the power of what? 2 equals to 0. Okay, so I will treat this separately. There's a statement in math that says, if I have a raised to the power of 3 minus b raised to the power of 3, this can also be expressed as a minus b into, close the brackets, into brackets, a raised to the power of 2 plus ab plus b raised to the power of 2. That is for this. Why? For this, I will make use of difference of 2 square. That is, if I have a raised to the power of 2 minus b raised to the power of 2, this can also be expressed as a plus b, close bracket, open under bracket, a minus b. If I expand this bracket, I will get this. If I expand this, I will still get this. Okay, now this tallies with this, while this tallies with this. So what if I compare this and this together? My a here is equals to what? X. While my b here is equals to what? 3. Okay, so anywhere I see a, I will replace it with what? X, and anywhere I see b, I will replace it with what? With 3. Here I have what? Instead of me writing this part, I will write it in this form. I will have my a is equals to what? X minus my b is equals to what? 3. X square plus 3 times, my a is equals to x and my b is equals to 3. So 3 times x will give me what? 3x plus b square, that is 3 square. That is 3 square. That is 3 square. So I've represented this in this. What about this side? So let me represent this side now. Plus, I said this can also be expressed like this, which is exactly the same thing as this. And my a, if I compare this and this together, my a is equals to x, my b is equals to what? 3. So my a here, I will represent a here with x and my b with 3. So I will have x plus 3, x minus 3. Everything equals to what? Equals to 0. Okay. Now, you can see that here I have x minus 3 here. X minus 3 here is common in both. So I will need to factor out x minus 3. X minus 3. If I factor out x minus 3 here, I'll be left with this, which is x squared plus 3 x plus this 3 square is same thing as what? 9. Now, I've already factored out x minus 3. So, what am I left with here? I'm left with x plus 3. That is plus x plus 3 equals to 0. Now, I will apply zero product rule. And what does that say? Zero product rule says that x minus 3 equals to 0 or this equals to 0. That is x minus 3, this first one will be equals to this 0 or this equals to 0. That is x squared. Now, plus 3x plus x will give me what? 4x plus 9 plus 3 give me 12. That is 12. Okay, equals to what? Equals to 0. Now, if I bring this minus 3 to the other side there, it will give me what? 3. That is plus 3. So here I can say x equals to 3. That is for this one. What about for this? This is a quadratic equation on its own. So I will need to break this one further. I have x raised to the power of 2 plus 4x plus 12. So we use our quadratic formula that says minus b plus or minus the square root of b squared minus 4ac all over 2a. So how can we get the value of a, b, and c? To get the value of a, b, and c, I will need to compare this with x raised to the power of 2 plus b x plus c. Mind you, this is equals to 0, equals to 0. If I compare this, now this x squared, this x squared. So the value of my a here is the coefficient of x squared here. So what is the coefficient of x squared here is equals to what? 1. That is my a equals to 1. And my b, this x, this x. So my b will be equals to what? 4. B equals to 4. And my c is equals to what? 12. C equals to what? 12. So I will substitute all this into this formula. I have. So now instead of me writing b, I will write what? 4. I will have minus 4 plus or minus roots. Here we have b square, right? And my b is equals to 4. So I will write it as 4 square. 4 square minus, here I have 4ac. That is 4 times a times c. So that will be 4 times, what is my a? 1. 4 times 1 is equals to what? 4. Times c, which is 12. So 4 times 12 is equals to what? 48. 48. All over. I have 2a here. A is equals to what? 1. So 2 times 1 is equals to 2. So here give me 2. Okay. So here I have minus 4 plus or minus the square root of 16, because 4 square is equals to 16 minus 48 all over 2. So this gives me minus 4 plus root 16 minus 48. That is minus 32 all over 2. So here I have minus 4. This plus or minus root. This 32 minus 32, I can also rewrite it as root 32 times root minus 1. Still the same. All over 2. So I can further break this one as minus 4 plus or minus root. I can break this one to be what? Root 16. This 32 times root 2. Which will still give me root 32 times root minus 1. Minus 1. Everything all over 2. So here I have minus 4 plus or minus root 16 is equals to 4 root 2 multiplied by this root 2 times minus 1, the square root of minus 1, because minus 1 is a complex number. So the square root of minus 1 is equals to I. That's I. Everything all over what? All over 2. Now, I want to factor out 2 here because 2 can go there, 2 can go there. So this is the same thing as 2 into brackets minus 2 plus or minus 2 root 2i all over 2. If I use this 2 to open this bracket, it will still give me this. So this 2 will cancel this 2. Here I have minus 2 plus or minus 2 root 2i. So I can write this separately as minus 2. I will consider the plus first, plus 2 root 2i, or I will then consider the minus for the second time. Minus 2, instead of me using plus, I will consider the minus now. Minus 2 root 2i. Okay? So I can still I can still factor out 2 here. I have it as 2 into brackets minus 1 plus root 2i, or 2 into brackets minus 1 minus root 2i. So these are the two answers that are not real. Why the first one we got here is the one that is real. So our answers are, we have x equals to what? 3. We have x equals to this, that is 2 into bracket minus 1 plus root 2i. And we also have x equals to this, which is 2 into bracket minus 1 minus root 2i. So these two are not real. Why this one is real, these two are not real. This is our final answer. Subscribe, like, comment. Thank you.